This is problem number 12. For which one of the following equation is the delta H of the reaction equal to the formation enthalpy of the product? All right, formation enthalpy, okay? The requirement will be coefficient should be 1, okay? So this one is not good. All right, so you should not have two of this. If you want, see this one, you don't know whether you're doing the formation energy for this part or this part. So it always should have only one product on the right side. So this one doesn't work. All right, so it could be possibly this one or this one. Okay, so let's look at this. Is this the simplest state of oxygen? Elemental oxygen, it should be O2. Oxygen is a gas at room temperature. All right, so this one is not right. Okay, what about the other one? Okay, let's check this. In room temperature is gas, fluorine is gas, and this one is gas. One coefficient, that's good, and it's balanced. Okay, so the answer is A. All right, for which one of the following the reaction is the value of delta H? The reaction will be equal to the formation enthalpy. All right, so let's look at this. Remember what I said before? The coefficient should be 1. Okay, so this one is not good because the coefficient is 2. This one is not good because the coefficient is 2. All right, so how about this one? Okay, first let's check if it's balanced. Okay, so I have 2 hydrogen on the left side, and I have, oh, by the way, so formation energy, each of the ingredient, it must be elemental. See, this is a big molecule, so it's not right. Okay, so this one is not right. Okay, so the answer is D. The equation is not balanced. Well, let's see if it's balanced. So 2 hydrogen, 1 oxygen. Actually, the equation, it is balanced. So this is not the reason. The reason is it's not in its elemental form in the reactant. That's the real reason. So this explanation is not right. The answer is right, but the explanation is not right. All right, so we have to satisfy all those conditions. Remember the conditions? Okay, it must be one single thing on the right side. The coefficient should be equal to 1. On the left side, the reactant, it must be elemental. It must be in its simplest form, and the equation must be balanced. This one is not in its elementary form. All right. Okay, we went over this. Okay, so this is kind of by using Hess's law. So if I want to know the formation enthalpy of this one, how do I do it? So what is the definition? Definition is the coefficient must be 1. So how do I turn? Okay, before everything, I want to write this number over here, -3351 kJ. Okay, so I wrote that here. All right, so this is not the formation enthalpy because the coefficient is 2. So I have to divide everywhere by 2. So this divided by 2, I have Al. This divided by 2, I have 3 divided by 2 oxygen. And that will give me Al2O3 solid. Okay. So if I divide everything by 2, this number I also have to divide it by 2. So this number divided by 2, which is -1676. Okay. All right. So this one would be calling it formation enthalpy. And on the left side is already in its elemental state, and it's the simplest state. All right, I think we're done.